let's talk about it. Let's do what we can with 22 minutes. All right. So, I'm going to go over the ones I think are most needed. You have all the answers on your thing there, but let me go through them. Number 5. I'm going to go quick, and you'll have it on the YouTube if you want to look back over it. Okay, Malia, $14, blah, blah, blah. What does she value? Chocolate twice vanilla. Let me change the color of the pen here. Come on. So chocolate twice vanilla, vanilla twice strawberry. Who are you supposed to start with? Remember, we did one of these a minute ago. Well, an hour and a half ago. Start with the lowest one. Remember, you start with the lowest one. So what's her least favorite flavor?
Strawberry.
Yeah, chocolate twice vanilla. Vanilla she likes twice as much as strawberry. So strawberry is the lowest, right? Strawberry is the lowest. So call that one X. Remember, you start with the lowest one. You call that one X. You build up from there. Vanilla is twice strawberry. So vanilla will be 2X up here, right? And then chocolate is twice vanilla. So it'll be 4X. There. We good? All right, so start with the lowest. All right, so what does that mean? What is the value of piece 1 to Malia? Piece 1. What is piece 1? Kind of hard to tell. Okay, so piece 1 is this piece. Oh, it goes halfway into that one, doesn't it? There. So there's piece 1. Basically, what is it?
Degrees, essentially.
Yeah, they're giving me degrees.
Each slice is 60 degrees.
Oh, wait a minute, no, what am I doing? I'm getting all messed up. Piece 1 is just this, huh? Piece 1 is just this. So in the end, piece 1 is just half the vanilla. It's half the vanilla. It's half of 2X. It's just X. Good? See how it's half? How do I know that's half? Well, I mean, I don't want to get all technical. You can just kind of look at it. You can eyeball it. That's fine with me. Technically, all the way around 360, right? All the way around 360. So if there's 6 pieces, 360, you don't have to do all this, but if you want me to prove it formally, 6 pieces evenly, 360 divided by 6, they're 60 degrees each. So this must be a 60-degree piece right here. And this says 30 and 30, so that's 60 also. And if it's 30 on this side of the white, it must be 30 on that side, so it is. You know, long story short, yeah. So this piece 1 is half of the vanilla. Now, well, I'm supposed to add all these up, right? 4X plus 2X plus X equals what? $14. Remember, you put in your X, and you start with the lowest one, X, double that 2X, double that 4X, add them all up to be $14 value. The whole cake's worth $14. What is that? That's 7X. That's 14 divided by 7 divided by 7. And so that X is 2. So X is 2. So that means then that this part is worth $2. This part's worth $4. This part's worth $8. And then this piece 1 here is half of the $4 piece. $2. B. $2. Does that make sense? We good with that? All right. Number 6. Suppose the choosers value the slices as follows. Blah, blah, blah. All right. Which of the following is a fair distribution? How many people we have here? 3. So with 3 people, you're supposed to take 100%, right? Because we're talking percentages, so all of it would be 100%. Divide by 3. You're going to get 33.3. Don't forget about the 0.3. You know, 0.3 is forever. 33.3%. See what I'm doing? You always take the total. Whenever you want what's a fair share, it's total over number of people. Right? Right? What if we had $100? What if I suddenly found, what if the dean just came in and said, hey, there was $100 sitting in the hall. Nobody wants it. Why don't you guys just divide it evenly? What would be even? I would take $100 divided by 2, me and Carl. No, that wouldn't be even. $100 divided by all of us, right? You divide by the total. That's fair. So you always take the total over the number of people, don't you? That's what fair means. So 100% is total when you're talking percentages. So 33.3, that 0.3 matters. So when you look at this chart, let me circle the ones that are that or more. Fair. 40, 37, that's it. The rest are under fair, aren't they?
Like 37?
Because that's more than 33.3.
Oh, okay.
Why is your test?
I have a 32 for chooser 2.
Yeah, your test is a little different.
Oh, is it different?
Well, just that one.
That's weird.
Yeah.
It was
Oh, shoot.
choose a
Is that a
two.
field test?
Maybe that explains that, maybe your Scantron answers aren't right then. It's different? Shoot, I updated it or something, huh? Forgot I did. You guys have something different, huh?
Well, just the choose a two is 32, 32, 36.
Yeah, and then.
Wow, that's weird.
30.
Was the other, last question the same?
Yeah.
Yeah.
Oh, weird. Yeah, whatever. So you have to do the same thing on yours. So you get the idea, right? So the ones that are 33 or bigger are fair. 33.3 or bigger. So at least on my problem, choose which of the following is a fair division of the cake. I don't know which one's a fair division of the cake. So chooser 1 gets S2. Chooser 2 gets S3. No, chooser 2 doesn't want S3. No. So A is no. Do you see why A is no? Chooser 2 does not want S3. Here's S3. It's under 33.3. At least on mine. Right? At least on mine. Anything under this, no go. B, divider gets S1. You don't even need to think about the divider. Divider cuts them all fair in their eyes. So don't even let that bother you. Just move on. Divider, whatever. Divider's always happy. Choosers 1 and 2 divide S2 and S3 combined together. I don't know. Yeah, I guess that could work. That's a weird thing. Chooser 1 gets S1. No way. That's not going to work. Choosers 1 and 2 divide S1 and S3. No. It's not, it's going to, the answer, at least on mine, is going to be B. That's kind of a weird question. Basically, why is it B? Why can choosers 1 and 2 divide S2 plus S3? Because S2 and S3 put together, at least on my test, in both their view is more than a double fair share. What's a double fair share? 33.3 is one fair share. Add another 33.3, you get 66.6. That's a double fair share, right? So those two would be happy if you gave them together a double fair share and told them to divide it up, right? So these two make 70, at least on mine, 40 and 30. These two make 69, right? I just added these and added those. So in both cases, it's more than 66.6. So in both cases, S2 and S3 are more than a double fair share to those guys. So yeah, they would both be happy if you said, hey, here you guys go, divide this. They'd think, yeah, we're getting more than a double fair share, let's divide that up. They would think that's fair. That makes sense? Whereas D, they would not. If you gave them S1 and S3 and said, divide that up, guys, S1 and S3, look how chooser 1 feels. S1 and S3, add them up, 60% only. Double fair share is supposed to be 66.6. He would think, you're not even giving me a double fair share. And you want me to divide this up? I'm not going to get a fair deal here. Make sense? So it's not D, at least on my test. Does that make sense? So that, we didn't really cover one like that in the homework. That's why I want to go over these practice examples again. Does that make sense on that? If they tell you to put two together and divide them, it's got to be a double fair share. And fair share, what if there were 4 people? What if they, I don't know what the real test has, I don't even remember. But the real test might have 4 people. So you take 100 divided by 4, it'd be 25% is a fair share. And a double fair share is 50.
You just make an average out of all of them, essentially.
Right. Right. All right, good. So I'm probably spending too much time that I don't have. Okay, there we go. So that one, 5 players are cutting a cake and da-da-da. Assuming all players, what player was the divider? Who was the divider? Can you tell us by looking? Is this the same question on yours?
Wait, hold on.
Close. Who was the divider? Yeah, D always stands for divider. No, I'm kidding. Sorry, it's just because the numbers are the same all the way across, right? They're all 2, right? That's how you know the divider? Same numbers all the way across. That's the divider. Remember that? Because the divider makes them all, he's the one that does the cutting. And he will do it so they're equal because he gets last pick. He'll make them equal in his eyes, according to what he values, always. Because the divider, the cutter, gets the last pick. So that's what they do. So you see somebody has all the way across, they are the divider. Right? That good? So who's the divider? D. Number 8, assuming he plays honestly, what should be player C's declaration? So what should player C, declaration means what is fair to him.
And I'm assuming the highest is, well, you're going to find the average.
Yeah.
Find the average for each person, right?
Yeah, exactly. So for C, we're gonna have to do the total. Somebody have that? What's the total for C? 2, 350, 455? I think it's $5.
So it's $1.
Divide by 5, right, it's $1. So there's 5 people, right? So you always divide by the number of people. So I added up all of C's money, 350, 455, yeah, $5 divided by 5 people. So $1 or more is fair to person C. Does that make sense? You always take the total. Remember, fair is always total divided by number of people. That's what it means, right? To be a fair, if I find the $100, we divide it by the number of people, right? So, right? So total divided by number of people. So $1 is a fair share. $1 is a fair share. So which ones will C think are fair?
That's 5.
$1 or more. So S1, S5. Yeah, both S1 and S5. So that's what C would declare. Yeah, answer A, S1 and S5. Is that good? S1 and S5? 9. Which of the following is a fair division of the cake? So that you're going to have to work harder. You're going to have to go through and underline all the ones that are fair for everybody. You could, but if you don't have time, you could rule some out real quick. We already know that C wants S1 and S5. Let me see. C gets S1, C gets S1, C gets S1. Oh, those all look fair. They're not helping us out. I was hoping we could eliminate some. Those are all working for C. You got to do the same thing for everybody else that we just did for C. You know what I mean? You got to go. You got to do the total. What's the total here?
Well, I know S.
5, 8, 12, $15 divided by 5 is $3 for A. So who does 3 or more for A? This one, this one, this one, this one. See what I just did for A? You just total them and divide by 5 because that's a fair share, right? That's fair for that person. Total divided by number of people. Everybody getting that idea? Right? Total divided by number of people is a fair share. So I just added up A real quick. $15 total divided by 5 people came out $3 fair for A. Then I underline or circle or whatever all the ones in A's list that are $3 or more because those are a fair share. Let's go for B now. Now I got to do B. So for B, what's the total? Add them up with your calculator. 7, 8, 15, 20. 20 divided by 5. $4 is fair share for B. Who's $4 or more? This one and this one. Only those two for B would he consider fair. So I'm underlining all the fair options. That's how I'm going to be able to answer question 9 about what's a fair division. Let's go to D.
That's 10.
So for D, what's the total? Is it 10, 4, 6? Oh yeah, they're all fair. D's the divider. D's the divider, so they're all fair. Don't even waste your time there. Let's go to E.
Same thing. 10.
Is it 10 again? 4, 5, 6, 7, 8, 9, 10. So $10 divided by 5. $2 is a fair share. So boom and boom, those two. All right. So now we can hunt down, is A a fair division? Well, A gets S4. Does A want S4? Yeah. Right? See how A has S4 underlined right here? See that? So far so good. A gets S4. B gets S2. Yeah, B has S2 underlined. C gets S1. Yeah, C likes S1. D gets S3. Yeah, D wants anything. D's the divisor. E gets S5. Yeah, that's good. A's a fair share. Yeah, yes. But keep writing. It might be more. Let's try B. A gets S4. Remember, you got to check all the options here. Yes, that's right. B gets S5. Yeah, that's right. C gets S1. Yes, that works. D gets S3. This is going to work for everybody, huh? Yes, that's true. And E gets S2. Yes, that's another. As soon as I've got 2 yeses, I can say all these are fair. I don't need to bother checking the third one, right? If 2 of them were fair. Oh, no, actually, it could be none of the above, huh? No, there could be 2 fair ones. No, it's D. Oh, they're all fair. I don't have time to do more. Check it. Yeah, they're all going to be fair divisions. Let's go on to number 10. Often tricks people. And, well, it's 15, 16, and 17, right? There's 3 questions associated with it. I think if I help you, I can get you to where you'll all get it right on tomorrow's test. Whereas the other ones are hard. That other one, I could spend an hour with you and I'm afraid half of you still might miss the other sealed bids. It's hard, it's a lot of calculation. But this one, hold on with me for 5 minutes. You can all get these right on tomorrow's test. First thing you need to do is you got to number them. Remember? Remember me saying that yesterday? I hope you remembered that. Definitely remember that tomorrow. That's when it'll count. Number them. What do I mean number them? Start with A and do A1, the next day A2, and the next day A3. We just need the numbers. That'll help. Okay, and then now go and do B. B1, B2, B3. And now do C. C1, C2, C3. And now do D. D1, D2, D3. So left, middle, right. 1, 2, 3. Now, Cole was asking a good question. He was saying, hey, the other one we did yesterday, they kind of mixed them sometimes. That's true. That can happen. Turns out this one didn't. You know what I mean? I mean, you could have A2 here and like D3 is coming before A2. That could happen. You know, like maybe D1's over here and D2's here and D3's there and A1's here and, you know, they can mix around. But whatever, just one letter at a time. A1, 2, 3, B1, 2, 3, C1, 2, 3, D1, 2, 3. Just do them one at a time and whatever happens, happens. Okay, now, remember the method. What's the method?
First letter.
First number 1 on the left. So who's the first number 1 on the left? A1. Boom. That's for A. So don't even, by the way, don't even look at the questions until you've got it all broken up. Then the questions will be a snap. So just, okay, that goes to A. That's A's candy right there. Now, take A out of the equation. A is done. A has got your candy and go, right? A is done. Now, the first number 2 on the left. Who's the first number 2? D2. So D2, and we always go left. Go left. You always go left. To same letter, though. Right? What do I mean? So here's the D, and how far left does it go? To the other D mark. That's D's candy. What about candy 2? Leftover candy. Candy 2 is going to be a leftover candy. You see how I did that? I just found the first number 2 mark, the D2, was the first 2 other than the A2. A's out though, right? So I'm not even looking at A anymore. The A2's out. A got his candy in step 1 and he's done. So the first number 2 mark, other than A2, is D2. And then I go left to the other D mark, right? That's what it means when D put his marker here and here. He was saying, I think candies 3 through 7 are a fair share. That's what D was saying when D put his markers there. He was saying, if you give me 3 through 7, I'll think I got a fair share. So give him that. Don't go all the way back to 2, just because it's there. No. You give D what he marked out, not more. Right? The 2 will be a leftover candy. That's I belabor that point because that's the mistake most people make. They go too far back. So that makes sense. You're only giving sections that they actually marked out. D marked out 3 through 7. Okay. And then the first number 3 on the, oh, by the way, D's out. Take D out of this program now. D, bye-bye. D, bye-bye. Okay, now the first number 3 from the left. What's the first number 3 marker? C. Let's grab the C. C3, and how far left am I going to go? To the other C marker. That's C's candy. Between the 2 C markers. C mark goes out, saying I think candies 10 through 14 is a fair share for me. Does that make sense? Finally, the last one, you go right. What letter do we have left? Who hasn't got their candy? A. We got A, D, and C, so it's B. So it's B, and we say, all right, B. B, there's your candy. B mark, put a marker there. So B was saying anything to the right would be a fair share. So we give B candy 16. So now the questions are easy. Question 15. Item number 8. What's item number 8? It's leftover. See it there? Leftover. Nobody got it. It's not circled. Item number 9. Leftover. It's like a trick question. Item number 15. They're all leftovers. That was like a trick. Leftover, leftover, leftover. Is that okay? You can get that, right? You can get that for sure tomorrow, right? It makes sense? Just label them. 1, 2, A, 1, 2, 3, B, 1, 2, 3, C, 1, 2, 3. First number 1, first number 2, first number 3. Remember just to go back to their letter, though. The last one goes right. All right. Money tomorrow. Or the big points tomorrow. All right, so let's do it. So number 24. These are the kind that are going to come from that table. Remember I said put that table that I wrote up on your 3x5 card and you get like 4 or 5 questions. All coming from that table. Here we go. Certain state, blah, 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 48.9 went to 47. That's a rounding violation. Do you see that? If you're at 48.9, the highest you should ever go is 49, and the lowest you should ever go is 48. Right? Because if you have $48.90, then you're between $49 and $48. So if we round up to 50 or down to 47, like they did, that's a lower quota. But right, it went too low, in other words, right? Shouldn't go to 47. The lowest should be 48 and the highest should be 49. It went too low.
We jumped it, huh?
We jumped it. That's a lower quota violation. It went too low. Now, look back at that chart. Which of those methods can do lower quota? I don't even remember. Is it Jefferson?
I didn't print it out.
So it's in the YouTube if you missed it or whatever. Where is it? I got it here. So who can do lower quota violation? Adams. Oh, I had it. And Webster. Adam and Webster. Adams, and Webster can both do lower quota violations. So they said Adams. They didn't say Webster, but that's fine. They said Adams. That could be Adams. Does that make sense? Connecting the dots for you? All right, let's try 25. Same kind of thing. These are the same kind of thing. 25. Certain apportionment, 48.9. Here we go again. Should go up to 49 or down to 48. And it went to 50. So it went to 50. That's an upper. Right? Upper violation. Who could do the upper? Isn't that Jefferson? Upper. Jefferson and Webster. So that's Jefferson and Webster. Jefferson, so there's Jefferson. Boom. Good? 50. Under apportionment method, let me get this out of the way. What are we talking about here? Apportionment, I can't read it. 52 seats. Okay, under certain apportionment method, state received 52 when the total number of seats in legit was da-da, but only 51, they went down when the number of seats went up. So look at that. The number of seats went up from 3 in the total house from 334 to 335, but they got less. That's Alabama, as I described it, right? The total, not like more candy bars, 12 candy bars, but Cindy got less. That's the Alabama. 27. Under certain, look at these percentages. Do you even need to read any more? 3% increase, another state, unchanged, years later, 10 years later, population is increased, while population statewide remains unchanged.
Now, that's kind of self-explanatory.
It's the population,
Yeah.
right? There's no new states coming in. It's just changing populations with states. It's the population paradox. All right, 28. Well, that's a lot of talk. What are they saying? Mother wishes 16 pieces. Yeah. Using proof, she gets boom, boom, boom. However, just before she hands out, she discovers that, there's like what I was saying. There's a neighbor Dave. So what's that? There's a new person in the mix all of a sudden. Do we need to read any more? New states. Blah, 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 blah. New states. New person. Right? Number 29, what's happening this time? Based on the time, right. Using Abe ends up with 9. So Abe gets 9. He should have had 7.8. So look, that's an upper quota violation, right? Cindy what did he get? Betty got 4. She deserved 4.8. That's possible. 3 for Cindy's. 3, that's okay. But Abe did upper violation. Yeah, that's A. That's a violation of the quota rule. That's A. Right? Because you see how Abe went too high? Abe, so you don't need to circle anything but Abe. See, Abe's the story there. Abe went from 7.8, and he should only round up to 8. He went to 9. That's too high. Too high. Carl, let me let you click. Sorry, I'm running late here. Let me let you click. No, my fault. I am in violation. It is me. I promise you guys to be out of here by this time. So there you go. Click A for Apple, and we're done. A for Apple.
Sorry.
You get your 10 points. No, you're good. All right, guys. There we go. Hang on if you got questions. Otherwise, I'll see you tomorrow. We have to start chapter 6, and then we'll take the test at the end. Last hour, like usual. It's a little painful. Sorry. It's the summer deal.